Okay, now that we've had an initial overview of the full spectrum laser cutter, let's go ahead and create files that we can insert into the software and actually cut. As you may recall, for 3D printing, the file type that we need is an STL. For the laser cutter, it is a different file type, and that is the XPS. So I'm going to quickly go through that using two different softwares to just familiarize you with how one would create those types of files. So if you recall from the initial overview, we were working in AutoCAD, creating this vector model. This is ultimately going to be a box that is a foldable box. And then we did a cartoon, we scanned this in, and I dropped this into Photoshop. So first, I'll go ahead and save this. So I'm going to actually print it. And if you notice in the printer setup, you can send it to any number of these. We're actually looking for this Microsoft XPS document writer. And we can just go ahead and print that. And something else I want to call to your attention, for Windows 10 and beyond, the file type actually has become an OXPS. Well, the laser cutter does not recognize that advanced of a file. So we actually need to go in and save it down to the prior file type of XPS document. So just like you might do in any other number of softwares, we're going to just go and save that to an XPS. And then I can save it to my desktop. Let's just call this Joker Final. And we have created the XPS for that. And then let's go ahead and do it for our AutoCAD drawing. I'm going to go into plot. And something about AutoCAD is actually it has the ability, we've selected your XPS document writer, and that does have the capability to be utilizing a full spectrum Hobby Series Generation 5 20 by 12 sheet. And the 20 by 12 is actually the cut range, the cut parameters for our laser cutter. So that's quite nice. In this case, I'm going to go ahead and select a window, and I'll just go ahead and window the object that we're going to cut. And I'll say, okay. Again, notice that the OXPS is the default. I want to change that to XPS, and we'll just call that the MakerLab Cube. Okay, so now they're on our desktop, and let's go ahead and launch the software for the laser cutter. That is the Retina Engrave software. This is looks like a diamond little icon there. We'll launch that. And we'll kind of go over the workspace, but first and foremost, let's just drop in the Joker image. So I'm going to file open, and converts it to a bitmap. So a couple things I want to call to your attention. First off, do you notice that there's a Raster Engrave tab, there's a vector cut, and then there's actually a design view. Quickly covering these three, design view is in fact almost a very rudimentary CAD capability area, drawing area. So we could create a number of different shapes. If you wanted to, let's say, just make a quick box or a very simple geometric shape to run a really quick cut on a material to see how many passes or what power, what effect you may have on that material. This is a really good, easy place to do it, so you don't have to go into an entirely different software and then convert the file, etc. Vector, if you notice, because this image is not lines, there is virtually nothing in this vector tab. So really, the only thing we have is in the raster option is here. Now, in its current form, this looks very, very harsh, does it not? I think you would agree. There's a couple things we can do to manipulate or kind of work with our raster image to see what the most desired outcome is for us. First off, if you notice, there is no dither right now. And so we can take this black-white threshold over here. It's currently 165, and we could completely darken it, or we could completely lighten it, or we could play with it to something around, let's say, this, if we wanted to. So this is a very stark option. This no dither is a very, very stark option. Now there's also what's called a simple dither. And that is, as you see, a little bit more of a grayscale, and we no longer have the option to do a black-white threshold. Halftone dither is creating a little more of a cleaner pixelation. And so depending on your image and how it's brought in or how it's scanned, you may want to play with these and determine which one you feel is the best final product for you. I like this. You know, it kind of almost looks cartoony or almost newspapery. So I'm going to go ahead and use the halftone dither. In this this toolbar over here, there are some additional tools that we can use. For example, we could rotate our object. This rotates at 90 degrees. And that's particularly important if you notice as I zoom out, there's this toolbar, or this ruler, excuse me, and this is the 20 by 12. So if we had a really large object, obviously we wouldn't want it to be portrait. We would be wanting to rotate it to be landscape. So again, we could, you know, rotate this to accommodate if needed. Something else we can do is we can scale it. And here we could set scale manually, like we could double the size. We also could specify the exact inches that we'd want it to be. And if you do notice, there is no, these aren't correlating, so you do need to be conscientious. You can very easily manipulate your image. You know, I can make it 10 inches in length and keep that 3.68 inches in depth or in height. So just something to keep in mind. So we could manipulate that. Let's take it up to the 1.75. There it is. And notice it does pop it back into, and it actually resized it again. So now we've got a very, very large image. That's okay. Let's go ahead and stick with that. Because I want to call something else to your attention. So as it stands, I'm taking it back to a halftone dither. It is currently about 18 by 11. Okay, so, you know, think of like a 11 by 17 sheet. This is just slightly bigger. Let's say we wanted to make almost like a poster or raster this into a piece of wood that was just about legal size sheet. We want to know how long that's going to take. And to give you some idea of the time difference between raster and vector, if we go down here, we have a time estimator. And this is a really nice tool that we can get a sense of how long our job will take. If we think about raster going all the way across, back and forth and back and forth and back and forth, creating these, basically these pixels, firing at the only, you know, each and every pixel, that's a very time consuming process versus just tracing a line. So if we were to estimate the time on this, it's almost 2 hours. So quite a long job. You know, obviously if it's something very important or potentially very profitable, that may make sense. So the last thing I'll call to our attention on the raster option is, if you notice, it calls it a vector layer, but there's really one and only one layer. So in default, this is the raster itself, the raster speed and power. There are no multiple layers that are available in raster option. It's just this one layer. And so here we could change the speed, we could change the power. We could even say we want to do multiple passes. And again, because it's a raster, it's saying that it's only recognizing one polyline. Now with passes, the nice thing is we could run an entire pass, and we could basically, if you can see this little red dot, that is in effect the laser being simulated right there. And it would go back and forth all the way down our image. And then when it is done cutting this image, it will go exactly back to this origin. So that's a really nice feature. We don't have to be concerned that it's going to lose that origin, or if we did want to do another pass after, that we would start in a different location. So that's something to keep in mind, that if we want to run one pass and then determine whether or not we want to run another one after, we can do that. So that, in a quick overview, is the raster option. So I'm going to go ahead and clear the workspace, and let's go ahead and drop in that Maker Lab box. It's one of these. And it's rendering the image. That actually might have been a bad, I think I created one file that was, let's try the newer, I think there was another Maker Lab cube. So notice it relaunches quite easily. I'm going to drop in again, and I think let's try this cube. There we go. Converting it to bitmap, it trims the white spaces. By default, it always drops your file type into the first tab, the raster tab. But keeping in mind, these are single line segments, and so we actually do want to use the vector cut. Another indicator that we can and should use the vector cut is the fact that we have imported these layers. And these layers were layers that we created right in AutoCAD, assigning different colors to them. So notice there's just this one color, but when we go into vector, it's a little hard to see, but the dashed lines are the green lines, and then our star is kind of the cyan. So here's our cube that we're going to cut out. And we only want to lightly score the dashed lines so that we can create folds there. And my idea was to just barely scar the paper or the material with the star so that it wouldn't actually cut through. And then all the black would be cut all the way through. So keeping this in mind, what we can do is we can ignore the raster. So we're going to turn that off. And then we can start playing with the speeds and powers and amount of passes that we want to do. So for the sake of this project, I'm going to keep the speeds at 100. Obviously, the slower you take your laser, the longer it has to expose over a particular area. And so essentially, the more exposure, the more burn. That can be a good thing or a bad thing depending on the material. Obviously, if it's a flammable material or something that could easily be melted, that might be problematic. If you do really want to, let's say, make an impact on a piece of very dense wood, that might be a time when you slow the speed down. Power, obviously, 100% is as high as it goes. If we're cutting something thin or lighter, in this case, I'm actually going to use a cardstock for this, then this 100% power is actually not necessary. We can really turn that down. And in the case of like these, creating just these dashed lines, we can take it down to a power of probably about 35%. The cyan, again, just because I want it just scored or just barely noticeable, I might even take that down to under 5%. Let's say 3%. And lastly, the black, the actual cutting of the outline on thick cardstock, more than about, let's say 70% isn't really required. And I think one pass on this cardstock, I'll show it to you when we actually jump into the laser cutter itself, will suffice. So moving forward here, we see that right now this is on a, it's basically on a a little over 9.5 by 13. Well, I have an 8.5 by 11 sheet. So I could go into this resizing right here, or I could even, in the case of the raster, or excuse me, the vector, I can push in these grips and maneuver it that way. So that makes it really, really quick and easy. Let's do a time estimator on this vector to give you a sense of how quick this is compared to our raster. Granted, this is smaller. We see it calculating. So this is not quite 3 minutes. So you can get a sense of, basically it will simply track these lines. And so it doesn't have to go back and forth and back and forth. It's just firing right along the lines as we've created them. So that is the general workspace. We see some kind of elementary tools over here. These are the main tabs that we're going to work in the different workspaces. This really is how we determine and assign our power and speed. We're going to utilize this area of the software to connect to our laser cutter once we're ready. And obviously this is where we can calculate the time. Last but not least, up on the ribbon up here, this is where we will control the laser in the machine itself. And the tools that we're going to use most are right in through here. As you see, we're in vector mode. We could change that in here as well versus in the tabs. When we get into the cutter, we're going to have to home our laser. We're going to have to send it to its origin. Once we do send it to its origin, we can run a job perimeter. And essentially what that's going to do is it's going to show us that the laser should run the perimeter of our cut to make sure that it is in fact seeing what we think it's seeing, as opposed to running a perimeter of, let's say, all the way like this. Then or like this. Then we know there's some kind of problem. So this is kind of the visual confirmation that we're on the same page as it. And once we have walked through preparing the actual cutter, then we would hit start job, and the laser would start to move along our lines, and we could actually watch that red line as it tracks. We could pause the job, and that would stop it right where it, once you hit paused. Or if you actually hit stop, it would go back to this origin point. So that's for a couple things. Let's say you decided, uh-oh, it's too much power, or it's not enough power. Let's send it back and let's change the power over here. This gives us the option to do that. So very quickly, this is the overview of the full spectrum Retina Engrave software. For the sake of time, this is the project that we're actually going to cut in the laser cutter when we start that in this next tutorial. So let's jump into the cutter itself.